Are you guys can able to hear me? Okay, great. Okay, thanks for confirming. So let us start the session, guys. So if you guys remember, yesterday I have told you about the demo one where we have discussed about what is data engineering. And let me just recap what we have discussed yesterday. Let me just mention the pointers what we have discussed yesterday. Yesterday's demo. So we have covered what is data engineering, what is Google Cloud Platform, and we have seen the course curriculum. So what and all we are discussing, I have told you what is the course curriculum. I have also given you the brief idea about the course outline, course details such as what is the timings and all of those details, how the material looks like, how the video recordings will be shared. Everything I have told you yesterday itself, guys. Those who have missed the yesterday's session, so please go and watch the yesterday's demo. Please connect with the admin. They will share you the demo also, demo video. Okay, so this is what is something that you guys can do it. So these are the things that we have discussed yesterday, and today onwards we are going to start with our Google Cloud Platform course. I'm going to start with our first topic, very first topic, that is why we need the cloud platform and what is the difference between the on-premises as well as cloud platforms. So if you guys go 10 years before or 15 years before, how people were struggling to work with the on-premises environment or traditional environment. Now, how the cloud came into the picture and how cloud is benefiting most of the companies, let us try to understand today. So this is going to be the very important topic so that you guys can appreciate the technology behind the cloud as well. Okay, so let's go into the deeper. So let us try to understand a very simple example. With that, I am going to tell you how you guys can understand this entire thing. Okay, so let me gonna talk about that, guys. Hope you all can see my screen clearly. If you guys are facing any issues with the audio or the screen, please let me know so that I'll get to know and we will be able to fix that problem. Okay, so now why we need the cloud platform, let me start. So before starting the why we need the cloud platform, let me gonna give you a very good example how actually projects work, how a company wanted to, for example, let us consider if a new organization is there, if an organization is there, they wanted to roll out a new application. Let's consider if an organization want out to roll out a new application, what happens behind the scene, let us try to understand. If a company wanted to come up with a new application, the business comes up with a requirement for the application. Okay, so if a company or an organization wanted to roll out a new application, the business comes up with a requirement for the application, and the business analyst will gather the needs from the business and analyzes it and converts it into a set of high level technical requirements. So whenever a company wanted to roll out a new application or release a new application, the business comes up with a requirement for the application, and the business analyst gathers the needs from the business and analyzes it and converts it into a set of high level technical requirements. Then this information will be passed to the solution architect. Now the solution architect will design the architecture to be followed for the deployment of this application. This may involve infrastructure or the specification type or the count of front-end web servers and the back-end web servers, load balancers, everything required for this application. He will create an entire architecture to be followed for the deployment of this application. Okay, so if that entire infrastructure is available in the company's data center, because 10 years before, 15 years before, we do not have a cloud platform. How the companies used to work, sir? The organization has to have its own data center. If the entire infrastructure is available in the data center, then there is no problem. If you follow a traditional model, this entire infrastructure to be available in the data center only. So that's where if additional hardware is required, they have to order it via procurement team. Look at here. So if an organization managing its own data center, look at here. So they have to maintain own data center. At that point of time, you do not have any cloud platforms. Okay, you do not have any cloud platforms. The company has to manage its own data center. In the data center, you will be having physical infrastructure and virtual infrastructure. Two types of resources will be there: physical resources, virtual resources. Okay, so when the business comes up with a requirement for the application, the business analyst will gather the information and analyzes it and converts into a set of high level technical requirements and passes this information to the solution architect. Now, the solution architect will understand the entire requirements and he will create a architecture diagram to be followed for the application deployment. And while he is mentioning all the architecture diagram, he will also mention what and all the infrastructure required for this application deployment. If that entire infrastructure is available in the company's data center, then there is no problem. They directly deploy the application on top of it. Most of the times, the infrastructure may not be readily available. What they have to do is that the solution architect, whenever the additional hardware is needed, they would have to order it via procurement team. The solution architect have to order it via procurement team. Now this team will put a request to the vendors team. Okay, so this is what happens, guys, in the traditional companies. So the solution architect, if the entire hardware or infrastructure is already available in the data center, there is no problem. But if the additional hardware is required, they have to request it via procurement team, and the procurement team will connect it with the vendors team. Now the vendors team will take a lot of time. Okay, now it will take days, weeks, even to months also for the entire hardware to be purchased and deliver it to the data center. So they have to purchase it and they have to deliver it to this particular data center. Okay, so that is what they have to do. Okay, so once the hardware is received at the data center, again the field engineers will come into the picture to take care of the rack and stack mechanism, and the system admins will take care of the initial configuration of the system, and the network admins will take care of the network configurations, and the storage admin will assign the storage to the systems, and the backup admins will take care of the backup. And finally, once the entire setup is ready, the application team will deploy the application or a code on top of this infrastructure. So this is how it happens. Okay, so look at here, guys. If when an application, when a new organization wanted to roll out a new application, so this is the entire thing that they have to follow. First, the business comes up with the requirement from the application, and then he passes that information to the business analyst. The business analyst converts this entire information into a technical, high-level technical requirements, passes that information to the solution architect. Now the solution architect will create an architecture diagram to be followed for the deployment of this application. This may involve the infrastructure details such as specification type, count of servers, front-end web server type, back-end web servers, load balancers, and many other things. And if the entire hardware is required, if that is available in the data center, then there is no problem. But most of the time, the hardware is not available in the data center. When you follow a traditional model, you have to deploy everything on the on-premises environment only. Okay, if the additional hardware is required, the solution architect will be connect with the procurement team. The procurement team will connect with the vendors team. Now the vendors team purchase the hardware and deliver it to the data center. Once the hardware is received at the data center, field engineers will come into the picture. Okay, the field engineers will come into the picture and they take care of the initial configuration of the system and rack and stack mechanism. So they will take care of the rack and stack. The system admins will take care of the initial configuration of the system. The network admin take care of the network configurations and make sure that entire these systems are available over the network. And the storage admins will take care of the storage and assign the storage to all of these systems. Backup admins will do the backup of these entire systems and storage. That's where the application team now, whatever the code that they have developed, they are going to deploy it on top of this infrastructure. So that's where your application is running in the infrastructure, your application is available for the users. So this is what happens, guys. So this entire process needs to be followed in a traditional working model. If our application or if a new company wanted to roll out a new application, if a company wanted to roll out a new application, they have to follow all of these steps. There are many teams involved, there are many people involved, there are many departments involved, there's a lot of infrastructure is involved. So this is what we call as a traditional working model, guys. In a traditional working model, your company, your organization has to manage the entire infrastructure for your application deployment. Your company has to manage the entire manpower as well as the infrastructure for the entire application to be deployed. So this is what we call as a working with a traditional working model. Okay, hope you all can hear me. But what is the problem, sir, working with the traditional working model? Can you tell me, sir, what is the problem? So the problem here is, try to understand, guys, the turnover times varies from the weeks to months for everything to be ready for the application deployment. You see here, the procurement team taking a lot of time, the vendors team will take a lot of time to be purchased and deliver it to the data center, field engineers, system admins, so everyone taking a lot of time. So that is the reason we call it as the slow deployment model. The turnover time varies from weeks to months to be everything ready for the application deployment. So that is the reason we call it as a traditional working model is a slow deployment model. Okay. And one more thing is that the overall cost to deploy and maintain this working model is very, very, very high comparatively. So that is the reason traditional working model is a very expensive. Look at here. So we need to maintain the data center. Data center 24 by 7, electricity 24 by 7, cooling or water supply 24 by 7, security and maintenance people, networking maintenance people, and field engineers, and many other teams here, procurement team, vendors team, system. So plenty of these people are involved, and we need to provide a lot of salary to them. 1 minute, guys. Give me 1 minute. Sorry, guys. So the traditional working model is very costly. Why I am saying very costly, you need to understand, guys. You see here, you may be thinking nowadays in the cloud platform, but you do not know how the data centers works, right? So in the data center, you need to supply the cooling every second. That means 24 by 7 water supply has to be there. 24 by 7 electricity, 24 by 7 security, as well as maintenance people to be available. And other than that, these many teams are working behind the scene. Application team, backup team, storage team, admin team, and field engineers and procurement team and vendors team. So many of the people are working behind the scene. We need to provide the salaries, we need to maintain this infrastructure, we need to maintain this data center. So everything taking a lot of time and a lot of money. So that is the reason the traditional working model is very costly. So that is the reason we call it as an expensive working model. And the very next point is that the limited automation. These are the challenges that you guys face as a traditional working model. The one more problem with the traditional working model is limited automation. Some aspects of the some aspects of the system can be easily automated, but most of the things cannot be automated. Look at here. The data center activities cannot be automated. Field engineers, what they are doing cannot be automated. System admins cannot be automated. Storage, maybe few things can be automated, few things cannot be automated. This cannot be automated, this cannot be automated. So most of the things are here not automated. So that is the reason the traditional working model comes up with a limited automation capabilities. Limited automation it is because most of the things cannot be automated. So that is the reason traditional working model is a limited automated model. And one more thing that I was telling is that with so many teams working on so many different tasks, there is a chances of human error is very high, which leads to the inconsistency in the environment. Okay, so many teams are working behind the scene, and many teams are when many different teams are working on a different tasks, the chances of inconsistency in the environment is going to be very higher. Okay, so this is what we call as a human error. It leads to the inconsistency in the environment. And the next point is that, which is a very important point, wasted resources, nothing but underutilization of the compute resources. So whatever we are buying, whatever we are purchasing the hardware, we may not be able to use it at least 60 to 70% also we may not be using it. So that is what it leads to the wasting the resources are limited, underutilization of the resources. So you are buying some kind of hardware, but you are not using the hardware even 50 to 60% of the hardware also you are not using. So that's where you are wasting the resources. You are underutilizing the resources. So this is also one of the major factor that is in the traditional working model, you are going to waste the resources mainly. Okay, so these are the challenges that people face when they are working with the cloud platforms or when they are working with the traditional working model, guys. So in a traditional working model, it is a slow deployment model. It is a very expensive model. The automation is limited. The human error is there, so which leads to the inconsistency in the environment and underutilization of the compute resources. Okay, so these many problems people are facing throughout a decade. So that's where they are looking for a one more alternative solution because they don't want it to manage this data center. They don't want it to manage this entire setup. So they are looking for an alternative solution. The companies are looking for an alternative solution. So that's where the era came into the picture. That is what we call as the cloud era or a cloud provider came into the picture. Okay, when the cloud came into the picture, you don't need to manage the data center. You don't need to have a procurement team vendors team. You don't need the field engineers, system admins, storage admins, backup admins. You don't need all of them. Okay, so this is how the cloud is benefiting for us. So yesterday when I said, so how the cloud is giving a lot of benefit to the organization, this is what is they are getting it from the cloud. So you don't need to manage the data center. 10 years before, 15 years before, every company has to manage their own data center for their own resource deployment or application deployment purpose. But now you don't need the data center at all. That is one of the biggest advantage that the companies are getting now. They don't need to focus on the infrastructure. They can focus on the innovation. So that is one thing. And one more thing is that so when you don't need to manage all of these things, tell me guys, is the cloud deployment model is faster or slower comparatively? I want you guys to tell me. So when you do not have a data center activities, field engineer, system admin, storage, so what is the deployment model, whether it is faster or slower? It's going to be the faster. It is because you are not maintaining. So the slow deployment model in the traditional, it is because we are taking a lot of time here. Now you don't need to worry about it. So that is the reason the traditional working model, it was a slow deployment model. But when you work in the cloud model, so it is a faster deployment model. Similarly, so when you are managing the data center, there was a lot of cost associated with it, and that's the reason you mentioned it as an expensive model. But when you are working in the cloud platforms, you don't need to maintain your data center because you can just create a resource. Hardly earlier we were creating a resource. If I wanted to work with the hardware, if I want the hardware, I may have to wait for months, weeks to months also we may have to wait. But when you are working in the cloud, if you want a resource to be created, it is hardly 15 to 20 minutes. Hardly 15 to 20 minutes. Where is 3 months? Where is 15 minutes and 20 minutes? Look at that. So that is the reason the cost of the similarly. So when you are maintaining the resources, it was a very expensive. 24 by 7 electricity, 24 by 7 cooling supply, 24 by 7 security personnel and maintenance and procurement team salaries, field engineer salaries, and the systems. So plenty of these teams are working behind the scene. So maintaining them was very hard, and that's the reason traditional working model was very costly process or expensive model. But when you are working with the cloud, you do not have all of these things. Now, the traditional model is a less expensive comparatively. And in the cloud platform, we are going to work everything with the APIs only. We are going to work with everything as the API, application programming interfaces. So that is the reason the chances of automation is very high. Can be automated. Most of the things can be automated. So that is the reason in the cloud platforms, the automation is high comparatively. You do not have that problem also. And in the traditional working model, many teams are working behind the scene on a many different tasks. But when you are working in the cloud, you do not have this team, you do not have this team, you do not have this team, this team, this team, this team, this team. The teams are very less. The chances of human error is also very less, which does not lead to the inconsistency. So there is no human error, there is no inconsistency in the environment. And when you are working in the cloud, you only use the resources which are required for you. You don't use extra resources, you don't use less resources, because in the cloud we have a concept called scaling up and down as per the requirement. So as per the requirement, you can easily scale up the resources or scale down the resources. So such kind of a thing is there. So that is the reason the wasted resources is comparatively less here. In the cloud, comparatively the wasted resources is less here. So that is problem is also not there. So these are the challenges. These were the challenges that the people were facing with the traditional working model, and these challenges are fixed by the cloud platforms. So this is how the most of the companies are looking towards the cloud platforms. It's because they don't want it to manage their own infrastructure, because managing the infrastructure is not easy. It is taking even months, sometimes even quarters also they are going to take. So to avoid that much of waste of money, waste of effort, so they need to put a lot of effort, lot of money, as well as lot of time, so that they can create an application in the traditional working model. But when you go to the cloud, your effort is reduced, you don't need to put a lot of money, and you don't need to take a lot of time also. It is less time it is going to take, less money, less time, less effort. So that is the reason most of the companies are looking towards the cloud platforms. Okay, in a simple word, if I have to say the difference between the traditional working model and cloud working model, an organization managing its own infrastructure to run their code and application, then we call it as a on-premises working model or a traditional working model. If an organization managing its own infrastructure for the application as well as code deployment, then that organization I'm calling it as a traditional working model. So what do you mean by infrastructure, sir? Every time you are mentioning infrastructure. An infrastructure can be a net servers or a hardware or a software or a networking or a storage. You can call anything as a infrastructure only. So if an organization managing its own infrastructure to run their code and application, then that organization I am calling as a traditional working model. If a cloud provider providing the services to the organization as a infrastructure as a service, then that company I'm calling as a cloud working model. So if there is a one company, that company is benefiting from the cloud services, then this company following a cloud computing model or a cloud era. So this is what is the difference, guys. So you have an on-premises working model where the company is managing, the organization is managing its own infrastructure. In the cloud computing model, who is managing the infrastructure, guys? So the cloud platforms are taking a lot of effort to manage the infrastructure. The companies are just creating the resources by utilizing those infrastructure so that they get a benefit of the cloud. So there is a less time, less effort, less money taken with the cloud computing model. The on-premises model is a cost-effective, slow deployment model, and human error is there. Underutilization of the resources will also be there. Now, when you go to the cloud platform, it is a faster deployment model, and it takes very less time for the application deployment comparatively, and the human error is very less, and utilization of the resources is higher here. So this is what is the difference between the on-premises and cloud computing model, guys. Does anyone have any questions? Please ask. If anyone have any questions, please raise your hand, guys, so that we will see if you guys have any questions. If anyone have any questions, please raise your hand, guys. On the difference between the traditional working model as well as cloud computing model, if you guys have any questions, you can ask me now. Yes, Faraz Khan. Yeah, that's it. So the effort is, for example, that's what I'm saying. When you are using the hybrid, when you say on-prem plus cloud, when you are using, so you are, so it's like this. It's a very simple. You can say, for example, this is on-prem. This is on-prem plus cloud. This is cloud. So you get a lot of benefit here. You get a less benefit here. So the benefits that you get in the on-premises cloud in a hybrid mode is medium. Okay, so that's what we can say. For example, it is a very faster. So for example, for the deployment, if it is taking here 100 days, here it is taking 50 days, here it is taking 75 days. So that is how you can say. The benefits are, in a medium range, I would say. Yeah. Okay, the automation is comparatively more in the on-premises, lesser than the cloud. The cost is also more than the cost is also lesser than the cloud. Sorry, more than the cloud, lesser than the on-premises. So that is how you are going to get a medium benefits when you are working in a hybrid mode. Hybrid is nothing but, guys, on-premises are a traditional plus cloud. Some companies works like this, so where they have their resources or a data that is there in the on-premises, but they wanted to create the resources in the cloud. So nowadays, most of the companies are working in this era. So you will be able to see 90% of the companies are working in this era. Very less companies still they are using the on-premises working model. Okay, so that is how it is. Yeah, any other questions, anyone? So that's the reason cloud is very important nowadays, guys. If you wanted to survive, or if you wanted to be with the technologies, or I wanted to go or upskilling myself to the technology, the cloud is very important nowadays. because without the cloud, most of the companies are not able to hire you, because most of the companies are looking towards the cloud platforms for their own innovation purpose. So that is the reason cloud is very important nowadays. Okay, so I see that no one is having any questions. So let me gonna go to the next thing. So as I told you, what is Google Cloud Platform? One of such cloud platform is a Google Cloud Platform. So far we have discussed, sir. So you see here, sir, we have a cloud provider. One of the cloud provider is a Google Cloud Platform, which is a leading cloud provider. So what they are going to do, sir? These cloud platforms are providing you the cloud computing services, which are helpful for you to build your application, scale your application, and deploy your application with Google's infrastructure. So that is what is Google Cloud Platform, sir. So Google Cloud Platform is a suite of cloud computing services provided by the Google that offers range of products and solutions for the organizations to build, deploy, and scale the applications and services in the cloud. So that is what is a Google Cloud Platform, and it provides you the highly reliable, secure, and scalable infrastructure. Okay, so Google Cloud Platform is one of the leading cloud provider. They provide you the cloud computing services. These services are very useful for the organizations to build, deploy, and scale and applications and services in the cloud. Okay, so this is what is a Google Cloud Platform, sir. So what are the services, sir? Can you show me what are the services for the sampling purpose? What are the services that the GCP is providing? So GCP providing you the compute services, identity and security services, management tools, networking services, big data services, storage and database services, machine learning services. So all of these services it is going to be providing you guys. Okay, so these are very less. Whatever I have listed here is very less. If you go to the Google Cloud Platform, let me open. So if you go to the Google Cloud Platform, so I'm opening the Google Cloud Platform, sir. So if you go to the Google Cloud Platform, so if you can look at here in the products and solutions, you can able to see all products. So you can see here, total, you can have a total 4,500 products and solutions are available in the Google's marketplace. You can use any of these products, all the products. You have a management product, computer resources, storage, analytics, and networking, distributed cloud, serverless, databases. So plenty of solutions are here. You can able to utilize these services, guys. So this is how Google Cloud Platform is providing you a plenty of services. Okay, if one wanted to do the networking, you have a networking services. If one wanted to create a machine learning model, they have a machine learning services. So for, if you wanted to work with the big data service, so plenty of services are available already. Okay, so that is what. And so if someone asking me why we need to learn the Google Cloud Platform, because Google Cloud Platform is having a very good some community support, and the service cost is very less compared to the other cloud platforms, guys. For example, look at here, if I have a Azure, if I have a AWS, and if I have a GCP, one virtual machine cost here, if it is $90, in AWS it is $100, in GCP it would be around $80 only. So Google Cloud Platform, it is providing you the services with a very less cost effective, with very less cost. So you are going to get the resources compared to the other cloud platforms cost effectively. So that is the reason most of the companies are looking towards the cloud platforms, Google Cloud Platform. So that's the reason nowadays there is a plenty of opportunities for the Google Cloud. And these services are flexible, these services are scalable, scaling up and down as per the requirement, reliable and trustworthy, and providing you the services secured and end-to-end encrypted is there also there. And these services also providing you the fully managed services. The interface is very fast. You can able to work with these services very faster also. Okay, so you have a very good community support, the cost effective services it is providing you, and flexible and scalable and reliable and secure and fully managed and faster services. Not only that, it is one of the market leader. Google Cloud Platform is a market leader, guys, because you have a AWS, Azure, GCP. These are the three market leaders. So one of them is a GCP. Industry adaptation is there. Comprehensive service portfolio is there. Integration and compatibility with the other services is also there. Machine learning capabilities it is providing you. Global infrastructure is there. It is very useful when you wanted to work with multi-cloud projects also. The certification and career growth is very high. So if you wanted to go for the Google Cloud platform. So the very simple agenda is that most of the companies are looking towards a Google Cloud platform. There is a plenty of opportunities to tackle those opportunities. We need to learn the Google Cloud platform. Why companies are looking towards a Google Cloud platform is this one. It is a market leader. Plenty of companies, even startup companies, mid MNCs, MNC companies, product-based companies are nowadays started using the GCP. Comprehensive service portfolio is there, guys. I have told you the source portfolio also. This is one of the portfolio. Few. This is a suite of services, nothing but a service portfolio. And integration and compatibility with the on-premises services also. It provides you the machine learning capabilities, global infrastructure, multi-cloud projects, and certification and career growth. So all of these things are there. So that's the reason we must learn the GCP. And you can also see here growth rate. The growth rate for the GCP is 54%, which is higher than the AWS and Azure. The growth rate for the last quarter for the GCP is more than the AWS and Azure. Growth rate means the company is choosing the GCP over other cloud platforms. And the roles are for GCP data engineer, GCP developer, GCP admin, GCP DevOps, networking. Plenty of things are there. Our main agenda is to focus on GCP data engineer. So in our course, we are going to mainly focus on the GCP data engineer, guys. And the next thing, the certifications offered. So if you wanted to go for certifications, associate cloud engineer certification, professional data engineer certification, you can always go for. Okay, so this is what is Google Cloud Platform, sir. I just wanted to stop it here. And if you guys have any questions, so we are going to enter into the cloud basics from tomorrow onwards. We are going to enter into the cloud basics from tomorrow onwards. The cloud basics, we are going to start with how to interact with the GCP. So these many services are there. If you wanted to interact with the GCP, we have console, we have Cloud Shell, we have SDK, we have API. So how to interact with all of these things, what is console, what is Cloud Shell, we are going to understand very briefly tomorrow. So I'm not starting it today. So it's going to take some time. So if you guys have any questions related to any of the course topics or any contents, you can ask me, guys, now. If anyone have any questions. If you guys have any questions, you can ask me, guys. So far what we have discussed today is that I've told you why we need the cloud platforms, right? So we have seen today why we need the cloud platform. So I've told you how the traditional working model works, how the cloud platforms came into the picture, and what is the difference between the cloud platforms as well as the traditional working model. This particular thing I will tell you later, guys. Even if I tell you, may not be able to understand it, but this particular thing I will tell you later. Introduction to the Google Cloud Platform and G Suite, and why we need to learn the GCP. And I've told you about the roles offered, the certifications offered, and we are going to start with the cloud basics from tomorrow. Okay? Yeah. Any questions, anyone? Please raise your hand. The installation I forgot to tell you. Yeah, we don't need to install anything. We can just create an account. Okay. So how do we work or how do we practice? If you ask me, guys, so we are going to practice like this. So I'm going to tell you how to create a free trial account. I forgot to tell you most how to create a free trial account. Okay, how to create a free trial account. So I'm going to tell you how to create a free trial account, guys. This free trial account is like of validity 3 months. 3 months validity. 90 days, I could say. 90 days. Okay, so this is one thing, first thing. And the worth of credits that they are going to give you is that the credits they are providing you is $300. So which is a very huge amount of money, which even though 3 to 4 members working on a same cloud account also, they cannot be able to exhaust this entire $300 in 90 days for practice purpose. So that is what. And you there is no restriction, no restriction on the service, but restriction on computations. So that is what is that mean? So you can use any service. There is no problem with that. You can use any service. You can able to work with the service, but they are not providing you the higher computational capability. That means they only give you the small machines for the computation. They will not give you high computation services. That means for all other services you can easily work. You don't worry about the computation also. But there are few, for example, if you go to the data proc, they don't give you the higher cluster size. They will only give you single node cluster. Okay, such kind of a computational restrictions are there, but I would say that for you it's a demo purpose. You are going to practice only. I would say you do not have any restriction on the service. Unlike AWS and Azure, you do not have any restrictions here. We can work with any service here for freely in the free account. Okay, so for creating an account, I will tell you how to create an account. So for creating an account, maybe I will tell you tomorrow or day after tomorrow how to create an account. For that one, you need to have two things. You need to have Google account, comma, credit card with 2 rupees. So this is more than enough for creating an account. I will tell you guys how to create an account. For create account, we need two things. These things we will cover maybe in our sessions. Maybe tomorrow or day after tomorrow, I will tell you guys. Okay. So this is how it is, guys. Okay, so we will be having with a free tier account, we will be having a validity of 90 days with $300 in credit. So there's no restriction of the services, but there is some restriction on the computer resources. We can create the account with a Google account. So I mean, when I say Google account, you can say Gmail account. So you can have a Gmail account, Gmail with the Gmail as well as credit card with 2 rupees. If you have these things, you can able to create it. I have created my account recently only. You can see here, guys. So if I go to the billing section, I'll be able to show you how the free credit looks like. So this is my free account only. You will be able to see here also free trial status, or you can also see here at the bottom. So this is how we are in a free trial credit. So it is of 24,724 rupees out of 25,000 rupees. So we are provided with the $300, nothing but a 25,000 rupees. Even I have used almost 90 days, it will come for you. So I have already used 20 days, but almost I have just spent only 263 rupees. That is only for the free. Okay, in the free trial, you are not using most of the resources. Even though you use resources heavily, also you may not be able to burn this entire amount. Okay, so this is how it is. Any questions, anyone? So I will tell you how to create a free tier account. We have a video also, guys. So I'll tell you maybe in our upcoming sessions how to create a free tier account. So I have created a video for that also, and the prerequisites and the step by step process to create a free tier account also. I have it here. I will tell you maybe tomorrow or day after tomorrow. Okay, so we are going to practice everything in the Google Cloud platform only. I am going to teach in the Google Cloud platform how to create and how to process the data, how to analyze the data, everything. PySpark, Apache Beam, SQL development, everything we are going to see in the sessions only. Everything we are going to practice here only. Even you are also can able to practice it with a free trial account. Okay, yeah. Any other questions, anyone? If anyone have any other questions, please ask me, guys. So we have like 10 minutes. You can utilize this time if you have any questions. Any question is fine. Correct, correct, correct. There isn't anything like better or something that. So I would say that AWS is famous for the machine learning, guys. So this is the community says because even I am a community member also. So AWS is very famous for the machine learning. Azure is very famous for the CI/CD, complete continuous integration, continuous. So GCP is very famous for big data, data engineering, big data. So that is the reason most of the big data projects, even from the machine learning, AWS also, they are moving to the Google Cloud platform because big data is very famous. In the future, you will be seeing more data engineering opportunities, even AWS, then you are going to see in the GCP only because big data is very famous in the GCP because it is providing you the cost effective services and it is providing you the services which are secure and reliable. Okay, so you have a plenty of services available for the GCP data engineering also. So that's the reason GCP is very famous. But if I have to talk about which is best, means all the cloud platforms are same. AWS, Azure, and GCP all are same only. But AWS was established market, Azure also established market, but GCP is growing like anything now, growing. Okay, so that is what we can say. Okay, yeah. Now, if I have to talk about the market capability, this is around 35%. This is around 27%. This is now 20 plus 20 point something, 20%. The market share. So that is how the market share. So you see here, it is just with the from last 4 years only you are hearing the GCP. Within last 4 years span only it is got the market of 20%. It's purely because of its own resources that is cost effective and reliable services. Okay, so that is how it is, guys. Any other questions, anyone? The main agenda is that if you are learning some course and sir, I wanted to go for a job, getting the job by learning some course with an established market is very hard because you have a established market. When you have a established market for the AWS, if you wanted to become a AWS or data engineer, you are competing with the skilled persons, which is very hard. Similarly, AWS also, which is very hard because you are competing with the established market where established data engineers will be there. If you are going for an interview, you are competing with those people who are having a very good exposure to the AWS and Azure because that market is established. Like you, people might have 10 years, 5 years before, plenty of the people are learned and plenty of the people are learned and already doing the job. You are competing with those people now and which is very hard to compete with those people with a real world example, real world experience. But GCP is only available from last 3 to 4 years. You don't find the skilled persons here, and getting the job is comparatively very easy here. So getting the job is very easy because you don't find the mark, you don't find the established skilled persons here because the market is not established yet. It is growing. When you are growing, you have a plenty of opportunities, but very less skilled persons, very less skilled persons. So that's where you can able to easily tackle the opportunities. So getting the job with GCP data engineers very easy, and the demand for the GCP data engineers is very high. Demand for the GCP data engine is very high now, guys. From the last 6 months, I am telling you, very huge demand is there for the GCP data engineer. Even today, also, if you wanted to check it out, go and just paste a resume in the Naukri and check it out. You will be getting at least 10 to 15 calls within one day only. So that's a very, very huge demand for the GCP data engineers. Most of the people does not know about it, and that's the reason they will go for here and they will attend the course here, they will attend the course here, but they don't get the job. No job, no job, because They do not understand the concept of that who is they are competing with. They are competing with the skilled persons. They are competing with the skilled persons. Getting a job with by competing with the skilled persons is that very hard. Okay, they go that sir, AWS is a established market, I will go, and Azure is a established market, I will go. You go, that's not a problem. But the thing is that getting the job is not easy. So if you wanted to just upskill, then go and learn an AWS and Azure. But if you wanted to get the job, I suggest you to go to the GCP. You don't need to trust me. Just wait for 2.5 months. You will only be able to see it. You will be getting the job, and you will only call me and say me that, sir, I got a job in this GCP data because the opportunities are like that. There are people who are getting 4 to 5 offer letters also. I'm telling you guys, you don't trust me. One of my friend itself who got 4 letters, 4 offer letters, and he's still attending for the interview. Okay, so that is how there's a very good demand for the GCP data engineers at this point of time. Okay, make use of it. So faster get into the data engineering as a GCP data engineer. Later, if you wanted to work in any way, because every cloud platform is same, guys. The technology is same. The platform is different. That's it. These are just platforms. The technology is same. Okay, so that is how it is. Any other questions, anyone? Just please. Correct. So we are going to having the cloud basics. So this is okay, cloud basics, I would say. So when I say cloud, our cloud is Google Cloud Platform. We are going to have a cloud basics. So we are started with this one. If you guys remember today, we have started with the module one GCP introduction. Why we need the cloud platform? We have covered. So we are going to strictly follow our notes, guys, only. So I will share my notes also here and cloud overview and the key services and products and understanding the cloud computing versus traditional working model. So this is what we have seen. Tomorrow we are going to see the interfaces, locations, IAM and admin, and the basics of compute options. And after that, we will be entering into the GCP data engineering topics. In GCP data engineering, we will be starting with cloud storage, cloud SQL, Bigtable, BigQuery, data proc, data flow, cloud PubSub, Airflow, data fusion, and Terraform. So here you are going to say, if I have to just categorize it so that you guys can understand it even more better. So let me gonna make it like this. We are covering PubSub instead of Kafka, both are same. Yeah, I'm gonna give you a simple outline, guys. So, for example, people say data lake, data lake. Sir, are we covering the data lake? Yes. Google Cloud Storage is our data lake. So, people say RDBMS solutions. Sir, are we covering the RDBMS? Yes, we are covering the Cloud SQL. Cloud SQL is one of the RDBMS solution only. Sir, are we covering the data warehouse? Sir, data warehouse is very important nowadays. Are we covering the data warehouse? Yes, sir. Very, very, very important data warehouse, highly rated data warehouse, that is BigQuery we are covering. Okay. And the next thing is sir, data processing. So data processing very important with the Spark and Apache Beam. Sir, are we learning here? Here we are learning PySpark in data as well as Apache Beam programming model in data flow. So these are the two services again, Apache Spark and this one. Okay, PySpark here learning in the data proc, Beam in the data flow. Again, these are the services. And for the workflow orchestration, sir, orchestrating purpose very important. Sir, can you tell me, are we covering the orchestration tool? Yes, guys, we are covering the orchestration tool, which is very famous tool, that is Airflow. Sir, streaming data ingestion. Sir, are we covering the streaming tool? Yes. People say Kafka and all, but in Google Cloud Platform, we have a PubSub which is similar to the Kafka only. So we are going to have a Here we have a batch pipeline and streaming pipeline also. Batch pipeline with the GCS, streaming pipeline with the PubSub. And also, sir, are we covering any infrastructure tools? Sir, infrastructure provision tool, infrastructure provision tool, sir. Are we covering anything? Yes, sir, we are covering the Terraform. Okay, sir, are we covering any event-based solution? Event-based, like if you go to the AWS, you have a Lambda. So event-based tool, are we covering anything, sir? If you ask me, yes, we are covering that is cloud functions. Okay, so this is all our course contents are for data engineering. So you see here, guys, so these are all services only. So this is this GCS for RDBMS solution. We are covering Cloud SQL, BigQuery for the data warehousing, PySpark and Dataproc. So these are the services. Dataproc and Dataflow for the PySpark and Apache Beam, Airflow. We are covering PubSub. We are covering Terraform. We are covering and Cloud Functions. We are covering. Okay, so all of these services you can see here: data lakes, RDBMS, data warehouse, data processing, orchestration, streaming, infrastructure provisioning, event based. So if you wanted to become a GCP data engineer, whatever the knowledge that you require, even more than that, we are covering in our. With the help of this course content, you can easily become the GCP data engineer. Easily, very easily, you can able to become the GCP data engineer with this course, I would say. Okay, yeah. So this is how it is. Any questions here, guys? Very simple. And one more thing, sir, I wanted to go for this GCP data engineer. I am providing you the resume templates. I am providing you the resume because you do not know how that resume would look like. It is not actually the resume. Resumes of previous students who got the job are placed, job holders. Okay, resume people, job candidates who got the job. So those resumes I am sharing. And one more thing is that I am sharing the theoretical, which is very famous for getting the job. Guys, very important for that one. Theoretical questions as well as coding questions. Coding, when I say SQL plus Python, all the coding questions are covered here. And we are also providing you. So this is material. Okay, I am providing you the full length material. So everything is mentioned here, the resume templates. If you wanted to go, once you have enrolled for my course, I am going to share you this notebook, guys. If I just share you the link, you will be able to access everything. So the resume templates, interview introduction, data engineering theoretical questions, data engineering SQL questions, Python questions, certification dumps. I am also providing you the certification dumps. Okay, yes, Rabindra Naik, sorry. That is covered, yes. That is covered in the PySpark. SCD type 1, type 2, type 3, overwriting the data, adding a one more record. Yes, of course, that is covered. Don't worry about that. Yes. So most of we are reading the data from the GCS. So the file formats we are covering, I would try to mention it, guys. So people will be worried about this one. File formats are, I would say, two things. I would say data sources. Okay, that is a very good idea, right? So the data sources are, we are covering the multiple data sources: CSV, JSON, Parquet, Avro, and text files. Sometimes we are reading the data from the MySQL and BigQuery. So these are the data sources we are covering. If you have your data CSV, JSON, and one more thing is GCS. So if you have your data in any of these file format in any of the platform, or MySQL tables, or BigQuery tables, or GCS, these are the data sources we are covering. Okay, most of in the companies also, most of the time your data source will be GCS, guys. GCS with any of these file formats, I would say, if I have to clearly tell you. So most of the times your data source will be GCS with any of these file formats. This is your data source. Sometimes your data source can also be MySQL. Sometimes, very rarely, your data source can be BigQuery also. So this is how it is. Okay. Any other questions, guys? Yes. Aleka Sompalli. Yeah. Okay, great. Any other questions, anyone? Okay. I hope it was. Sorry. Sorry. Oh, okay. Sorry, guys. I might have did not tell you about me, right? So yes, sir. My name is Shaik Saidhul. Okay, I am working at MNC company. You can always ping me in the LinkedIn. Also, I am available in LinkedIn as well. Yeah, hello guys. Wait a minute, guys. I'm explaining about myself. Okay, so far I did not talk about myself, right? Just let me tell me about myself to all of you guys. So my name is Shaik Saidhul. I've completed my masters from National Institute of Technology, Tiruchirappalli. Masters from NIT Trichy. You might have aware of it, NIT Trichy. Okay. So and after that I've started I mean it's almost 8+ years of experience that I have into the data engineering field. I also work in both environments, guys. I'm a data plus AI background, so I also work in the DevOps stream as well. So I'm a trainer for the DevOps also. You can always I mean you can also join my DevOps course as well with the GCP. So I usually teach Azure as well as GCP data engineering. Nowadays I'm only teaching the GCP. I'm a corporate trainer with the 2 years of experience as well. Okay, corporate trainer as well. And this GCP data engineering is almost I've been taught more than 30+ batches. Okay, for the GCP data engineering. GCP data engineering, I have taught more than 30+ batches. So this is how it is. My name is this one guy, Shaik Saidhul. So I've completed my master's degree from National Institute of Technology. Total, I have 8+ years of experience. With the master's, I have completed like 2 years, and corporate trainer and 30+ batches for the GCP data engineering itself. So I teach in for the corporate. I teach in Rakuten. So that is one of the company, and one more is there is this GC. Okay, that is also one more company. For I am a corporate trainer there, and currently I work for two companies. Quantech is my main company for full time. I work here, and I am a consultant at Databricks. I'm a consultant at Databricks also. Okay, so this is all about me, guys. Okay, I'm a full-time employee at Quantech. I am a consultant at Databricks for the solution building. So this is all about me, and education background, experience, and I'm having almost 2.5 years of training experience, guys. Teaching experience, I would say 2.5 years of teaching experience is there. So this is all about me. 2.5 years of teaching experience. So this is what. Okay, yeah. Any questions, anyone? I think this is enough about me. Yeah. I'm from Andhra Pradesh, I would say. I'm from Andhra, currently where we are having the elections. So I'm from Guntur, I would say. Yeah. So this is all about me, guys. Yeah. Anyone have any other questions? So data modeling, we don't worry much because data modeling is kind of outdated, I would say. But data modeling is not required for getting the job into the GCP data engineering, because that's more of a SQL developers, okay, SQL developers and ETL developers. They'll take care of it because we don't worry about the data modeling. Yeah. PostgreSQL is similar to the Cloud SQL, nothing but a MySQL Cloud SQL, which is similar. Yes. So you have, so this is how, guys, if you are working in a GCP data engineering, you have your GCP tools, which is similar to the AWS, which is similar to the Azure. So you have your own cloud native tools here. Okay, so that is how it works. Yeah. Any other questions, anyone? Okay, I think this is it. If anyone have any questions, please ask me, guys. So this is it for today. We will see. We are going to, I mean, we are already started the sessions, guys. Those things, these are demo sessions. No, guys, these are demo sessions for you because we are providing it for free for first 3 days. Okay, tomorrow also it is free from day after tomorrow onwards, everything is going to be done only for the enrolled students. So what you can do is that you can start doing the enrollments. That is one thing, and take serious things on topics that we are covering, because these are the serious topics only that we are going to cover. These are the topics that we have already entered into the Google Cloud platform. Tomorrow's session is again cloud basic topic only. Cloud basics we are going to enter into. So as per my, uh, you know, what we call as a curriculum, you can able to see here. Tomorrow we are entering into the cloud basics, GCP interfaces. Okay, so that is how. Okay, okay, guys. Yeah, 2 months. Yes, hardly it will take 45 hours, 46 hours. 2 months is enough. Yes, and I forgot to tell you, even it sometimes it go to 5 more days, 4 days extra, guys, because we have added from the last 2 batches. I've been teaching the Python basics. The Python basics also covered here, guys. I forgot to tell you, because we are covering the Linux basics. Linux basics doesn't take much time, hardly 1 hour. Linux basics, hardly 1 hour. And we are covering the Python basics from the last 2 batches, which is we have added it as a complementer, because people does not know Python for data engineering. So they do not know Python for data engineering. We are taking here, I think, 5 to 6 hours. So this is the extra time, I would say. It would take 2 months. Actually, I would say 2 months. Yeah, more than enough. 2 months is more than enough. Yeah. Maybe 2 to 3 classes, maybe extra also, but hardly 2 months, I would say, and an average. So this is how. Okay, don't worry about the Python also. We are having the Python crash course. Python crash. Python crash. I don't call it as a crash, but it's a crash for because I'm covering only for 5 hours. But I'm covering all the data engineering topics which is required for the Python for the data engineering. We are going to cover here. Okay, you don't find this Python for data engineering anywhere with this much of very clear content that I'm going to cover. I'm going to show you that also maybe one day, guys. Okay, yeah. Any other questions, anyone? In addition to these things, we are also covering these things, guys. Any other questions, anyone? Okay, okay, guys. Thank you all. Have a great day. We will meet tomorrow at the same time, and we will see our further proceeding topics. Okay. Bye, bye, guys. Have a great day. Bye, guys.